Hello. Today we'll be looking at section 11.6, solving all polynomial equations. In this section, we learn the fundamental theorem of algebra. In this theorem, it states, every polynomial equation p of x equals 0 of any degree greater than or equal to 1 with complex number coefficients has at least one complex number solution. In this theorem, it basically states, any polynomial equation which looks like this, if it's equal to 0, which is important, it can be put into the quadratic formula, and we'll be looking just at this part. If we look at that, b squared minus 4ac, if that section is less than 0, then it'll be a non-real number or complex number. And if the b squared minus 4ac is equal to 0, then it'll have an equal roots or double root. And if we put that on a graph, we look here and here. This is b squared minus 4ac equals 0 as graphed. And as you can see, it has 1 point on the x-intercept because they're both equal, which is called a double root. And it also has a complex root somewhere in between these two. And for the b squared minus 4ac is less than 0, then we can also see that again, but this time it doesn't have a real numbered root. It just has two complex roots between these sections. And what it has to relate to the theorem is that if the degree is more than 1, which the degree is basically how many roots it would have, so this parabola would have 2 roots, so there's a second degree. With complex number coefficients, so non-real, these two equations both have complex number coefficients. We'll have at least one complex number solution. So this equation or this graph has at least one complex root, such as this one too. As you can see, it doesn't have any real numbers. So yeah, that's all. Thank you.